Hello and welcome to yet another video. My name is Naveen Kumar and you're watching EduTech Physics. So today we are going to discuss about previous year, that is NEET 2021's question, right? So you can see the question down here. So we'll read the question and we'll try to understand from which topic this question was asked, and at the same time how we can do this question. So let's go into the question. A convex lens A of focal length 20 cm and a concave lens B of focal length 5 cm are kept along the same axis with a distance d between them, right? If a parallel beam of light falling on A leaves B, that is A is a convex lens and B is a concave lens, are parallel beam, then the d in centimeters will be, we'll try to understand that is concave lens and convex lens. This question was asked from the topic called #optics, which is a +2, that is array optics +2 topic. Okay, so we'll try to figure out how we can look at a parallel beam of light, how a parallel beam of light coming and falling on a convex lens, how it is happening. That is, if a parallel beam of light comes parallel to the principal axis, falls on a concave lens, convex lens, will pass through the focus of the lens, right? So that is why a convex lens is also called a converging lens. So we'll just try to figure out how we can draw a convex lens and how the light actually comes. So this is a convex lens, so we'll draw the principal axis, right? So let's imagine this is our focus. So this is our focus, right? So a parallel beam of light will come like this and pass through the focus. Similarly, we can take another light coming like this as well, right? So it will pass through the focus. What about a concave lens? So if I draw in a concave lens, and how the ray of light will behave. So if this ray of light comes parallel to the principal axis, that is, let's draw the principal axis as well. So yes, so this is our principal axis. So if a parallel beam of light comes and falls on the principal axis, what will happen? It will diverge away, in this case, as if the light tends to start from a point somewhere here. This is called the focus, right? So that is why a concave lens is also called a diverging lens. It diverges away, right? So a parallel beam of light, as it comes here, it tends to diverge away from the lens. So it diverges as if, sorry, the figure can be a little more better, right? So for understanding purpose, we are drawing as if it is the light is coming, right? So light is coming as if you are looking from this side, you will find that is the light is coming from this point, as if it is coming from that point. That is why it's called the focus. So we are going to combine these two figures in such a way that, according to the question, here the question says that the convex lens do have a focal length of 20 centimeters. So we are going to do that. Okay, so what is that? This is a convex lens. It has a focal length. It's the parallel beam of light is coming like this. It has a focal length of 20 centimeters. So let's imagine that this distance from the lens is your 20 centimeter mark. Okay, so the light will pass through the convex lens, right? But what is this said? So this is your parallel beam, right? So it's a parallel beam, okay, right? Okay, so right? So it passes through this point. But it is said that a concave lens of focal length 5 centimeter is kept along the same axis with a distance d between them, so that the beam which is coming out should go parallel. So that is what we have to look out here. So if it has to go parallel, can we think in opposite direction? Can we think in terms of this in an opposite direction? Right? So if it is thought of in an opposite direction, light should have to come like this, fall at this point. If it is falling at this point, definitely light would have been going like this. So we'll try to think in an opposite way, in such a way that light is coming from this side. Light is coming like this, okay, and it will go parallel. It will go, right, understand properly, it will go parallel only if light tends to fall or tends to concentrate at this point called the focus, the opposite direction. So what we are going to do is, the light has to come in like this. So what we'll do is, we'll consider this point to be this. Okay, so light has to come in such a way that the light should be merging or passing through that point. You should make the light to come in such a way that it has to pass through that point. So what we have to do, we have to make or draw the light or keep the lens in such a way that it has to go like that, right? So that is what we are going to do. What we'll do, we'll try to find out or keep a lens here somewhere. Okay, so it is said that the concave lens do have a focal length of, that is lens B, this is lens A. So B has a focal length of 5 centimeter. So if it has a focal length of 5 centimeter, right? Okay, so if it has a focal length of 5 centimeter, let it be this, right? Okay, so if it has a focal length of 5 centimeter, that is, this distance is 5 centimeter. Okay, so what is the distance between, you have to keep in such a way that, keep in such a way that the distance between the lenses is how much? That is our D. That is, D is how much? Okay, so light has, if it is falling like this, so if I am drawing a light convex lens like this, the light is coming and falling at this point, you are keeping the lens somewhere here, so it goes parallel. So the light is coming and falling it somewhere here, so the distance is 5 centimeters. Okay, so what happens? This distance is also 5 centimeter. So what happens? From this distance is 5 centimeter. At the same time, this distance is also 5 centimeters. So we can draw it like this. This side of 5 centimeters. So it will be better for you to understand. So what is the distance between? A to B? If the light is falling like this to this point, definitely the light, what will happen? It will go parallel. It will go parallel like this. You understood? I hope you understood. So what happens? This is a convex lens, this is opposite. Okay, so if the convex lens is trying to focus its light at its own focus, so what should be the distance from the convex lens to this? So what we have to do, this distance, what is the distance between the convex lens to the concave lens? What is this? The total distance from here to here is 20, this distance is 5, so the distance between them is 20 minus 5. So D is equal to 20 minus 5, which is equal to 15 centimeter is the right answer. This is just a logical question. If you know how an image formation of a convex lens is done and the image formation of a concave lens is done, you can do this. So 15 centimeter is the right answer for this question. I hope you understood. Okay, done.